Hi, I'm class 11 Lesson Grade 5 from Evening Primary School. We'll start a new course, and this course name is called Differential Equation. For differential equations, we have two of them. One is the ordinary differential equation, the other is the partial differential equation. For the partial differential equation, we'll learn it in the future. Right now, we'll just only focus on the ordinary differential equations, and their short forms are, for ordinary differential equation is ODE. For partial differential equations is PDE. This is ordinary differential equations, partial differential equations. Okay, when we focus on this ordinary differential equations, we only have two variables. One is the independent variable, the other is the dependent variable. Independent variable is like the x. The dependent variable is like the y. And the differential equation consists of three parts. We have the function, we have the function of x, or even the differentiation of the function. Differentiation can be the second derivative, the third derivative, the higher order derivatives. So for this ODE, we have many methods, but for this time we'll focus on the method that is called separation. Which one thinks we can separate those functions? But we actually can separate those into one side will be the function of x, another side will be the function of y. Actually, it can be called the function of the independent variable, while the other is the function of the dependent variable. Okay, so in the future when we have this partial differential equation, it is actually more independent variables, which we don't learn it right now. So here, remember we need to always find the y. First we can find what is y, then after that we can check whether our answers are correct, sub it back. Okay, is it alright? So can I start on these questions? Okay. So for this first question, which is the dy dx, and that is x squared plus 2x plus 5. So first for this, we'll need to move the the dx to the other side. Which will become like this. So right now we can both sides integrate. So here it is actually the indefinite integration. So here it will be the y plus the constant. Then here after we integrate, we'll also need to remember about the constant. So like this, we can move this constant to the other side. Which will just make it like this. Then after this part, okay, we get our answer. So let's check. What is the differentiation? So this part will have the x squared. Then this is 2x. And this is a 5. And of course the c's are 0. So let's see when we get this, would it be right? Okay, yes, it's the same. So that means it is actually correct. Okay, so this is for the first question. And remember, this checking can be called inspection or verification. Okay, so this is the first question. Next, we'll be moving on to the second question. So are you all clear of this? And can I erase it? The second question, which is the dy dx. And this is y squared plus 2y plus 5. Of course, we need to move all these y to the other side. And remember, we can't just simply divide, if not we can't integrate it. So we can only divide, not minus. So we have like this. Then both sides integrate. Then after that, for this part, denominator rationalization. I mean, completing square. Which this will be the first part, and then the second part we can straight away integrate. So for this, it will actually be the inverse tangent, because here we can put it as plus 1 because a constant doesn't matter for that. So this 4 is a 2 squared. So we have a 1 over 2. And this is the inverse tangent. And this is the y plus 1 over 2. And so this will be x plus c. Because for this constant, we can just straight away move it to the other side. Then after that, 2, we can just times it in. So best is to put this as a 2 first. Okay, after that, then we can put the inverse tangent come here, becomes a tangent. Then after that, both sides times 2. And when we times 2, we can just straight away move that plus 1 over here, become a minus 1. So like this is our y. So for this, we found our answer, but remember we have to check. So we'll just sub it inside here, and we'll also need to know what is the dy dx. And we can't forget about our chain rule. So it will be like this. Then after that, when we sub this in, so this will actually be the 2 tangent 2x plus c, then the minus 1, this whole thing squared. And then for this, the 2y. And then last but not least, that's 5. So this will be left alone. Then this part and this part will just cancel out each other. 1 plus 5 minus 2. So that will be a 4. So for this, we can just factorize that 4. So I actually realized that this part is a secant square 2x plus c. So here we have our answer. Yep, and it's correct. So this is for our second question. And remember, these are only those simplest questions. Okay, so question 2 will be just like this, and remember for these questions, they are separable. As this method, which is called separation. Okay, so can I erase this? Okay, everyone clear about this? Next we have the third question, which is dy dx. And this is the sine square x over y. So for this part, we'll need to move the y to the dy. Like this, and then the dx to the sine square x. So for this part, first we can have like this, the half y squared, and don't forget about the constants. And for this part, we actually need to use the double angle formula. The double angle formula, which is the cosine 2x. This is 1 minus 2 sine square theta. So the sine square theta will be the 1 minus cosine 2 theta over 2, like this. So we can put that in. So it's like this. And then after that, both sides times 2. Then after both sides times 2, here we can already integrate. Which we have like this. And then after that, we can move the constant to the other side. Like this. Then after that, we can find what is y. And this c is inside, so you'll realize that. And also there must be a plus minus. And for this, you'll realize that in indefinite integral, it's always at the end plus c. But for this, what is it called? It's a differential equations. It can be anywhere. It can be inside this square root. Like for the second question, it can be inside that tangent, the inverse tangent. It can be anywhere. And even sometimes like indefinite integral outside, or even as a coefficient. And let me just tell you, both of these can be our answers. But for this y, it is the explicit form. Well, for the y square, it is the implicit form. Implicit form, if you cannot like really simplify it further, or you does not know how to continue, you can just write it like that. It's fine. But if you can write it in the explicit form, it's better. Okay, so here we have our two answers. Well, it's actually only one. But the problem is the dy dx. Which one to use is simpler. Of course, it's actually this part. So first, these two will differentiate with respect to x. But the y square, first is with respect to y. So you have 2y, then after that, with respect to x. Well, this is actually the dy square, dy, then times the dy dx. So it's actually with respect to x, like this. So that is why you can have it like this. If not, you have two of these, and you don't know what can continue. So then after that, x will become a 1, minus a sine 2x over 2 will become a cosine 2 theta. I mean x. Then after that, for the constant, it's a 0. Actually, for this, our double angle will tell us that this is a 2 sine square x. Okay. Then after that, dy dx. You move the 2y over to this side. So it will be like this. So this part is the same. So it's correct. Okay, and this is for the third question. Okay, is everyone clear of this part? Okay, so can I erase this? So next up is the fourth question, which is the dy dx. And this is y over sine square x. So first for this part, we can move the dx to the other side and the y back there. Then after that, we can both sides integrate. So after that, for this dy over y, of course it is very obvious that it is a lot. Then for this cosecant square will be a negative cotangent square. Wait, I mean the cotangent. So for this part, then we can move the C1 to the other side. Which will have like this, and remember that C3 is C2 minus C1. Then after that, we can actually find what is y. So for this, remember the plus in the power, it is actually times e to the power of C3. It is actually a constant. And remember, this C, it is e to the power of C3. So we have it like this. And this is our y. So this is the explicit form. This is the implicit form. So right now we have our y. Next thing to have is check. But which one do we have? Actually this. So don't forget about that 1 over y. Like this. Then after that, the negative cotangent x differentiates with respect to x. Like this, is it right? So this constant no more. And remember for this, the cosecant is actually the over sine square. So we'll just need to move this to the other side. So this is for the fourth question, which you can realize that C has now become the coefficient. At first, in indefinite integral, it's always at the back as a constant. Okay, so for this we have like this. So is it clear for the fourth question? Okay, so I resolve these. So next is for the last question. Question number 5, which is 3x dy plus 5 bracket y plus 1 bracket dx, and this is 0. So we can just put this to the other side. So it will be like this, then we divide. Which will be like this. Then we can both sides integrate. So we can integrate right now, and remember for this, we actually can write as plus 1 because the constant doesn't matter. So here we can have it like this. And then for this side will be the 1/3 ln x. So here we can plus the C1. So for this side, we can both sides times 5. Okay, and then this negative we also can bring along over here, like this. Then for this ln, we actually need e to the power. So actually right now for this, we also can separate. E to the power of C2 is actually another C. And remember, C is e to the power of C2. So right now you realize ln and the e. So it can become like this. So it will just be like this, okay? So then we found our y. Now let's still check. So we can put it in so for this part, oh wait. Actually over here, for this we can just have our y and our x. And we also need our dy dx. So we can just straight away get it from here. which will be like this. Okay, and then after that, well, we can just put it into this place. Okay, and last but not least, the fifth question. And this fifth question is 3x dy plus 5 times y plus 1 dx. And this is equal to 0. So first we can move the part with dx to the 0. Then after that, for this, divide. And then both sides integrate. And remember that actually this can plus 1 because that for this the constant doesn't matter. So therefore that place we have this negative 1 over 5, and then we have the ln y plus 1. So this is 1 over 3 ln x plus the c1. Then we have both sides times negative 5. So we have it like this. Then to eliminate this ln, we need a e to the power. Which we have like this. And then we can put this as, okay, and remember for this e to the power of c2, we can write it as a c. Then for this we can, because here's a ln and the e, so we can just write it like this. Then after that, okay, we already found what is y plus 1, right? So we need to find what is y. And this is y. So right now we need to check whether it is correct. We need the dy dx, which we can get it from here. Like this. Okay, and then right at this part, dx, we can move it here. Remember, we want to try to get this to show that this is correct. So we can have this 3, both sides times 3. And remember, x is actually this x to the power of negative 8 over 3. Like this. Because that this is a negative 1, which is over x, so that is why we can times it over here. So like this. And then what's left will be this negative 5. C is still left. X will be just left to this part. And just like this. So then for this part, this is still the same. What is cx to the power of negative 5 over 3? Okay, it's the y plus 1. So we'll get it. It is the exact same. Okay, so this proves that it is correct. Okay, so are you clear for these 5 questions so far? Okay, if you're clear, then remember for these we are all separation. This is just the first method. And in fact, these are actually the simplest of those. And sometimes you'll realize that C, but you might say that in indefinite integral, they're always at the back as a constant. But in this case, we have coefficients. We have in the power, in the tangent, inverse tangent, all sorts. It can be anywhere. Okay, so for these, are you clear? So here we end our lesson here. And if you like our videos, don't forget to subscribe to our channel. So see you in the next lesson. Thank you for your watching.